We are almost done drawing Lewis dot structures. There's only one more thing that we need to consider, and that's how to draw the Lewis dot structure for a polyatomic ion. Now remember that a polyatomic ion is an ion that's made of many atoms, but collectively they have a charge. A great example of that would be something like NH41+, ammonium. The nitrogen and the 4 hydrogens collectively bond, and they have a charge of a +1. So let's start off by calculating the S equals N minus A. So as far as the need, remember that you're going to have to add together the need for the nitrogen and the 4 hydrogens. Now I just want to be clear, the fact that this guy has a charge, a +1 charge, does absolutely not affect the octet rule, which is where this need comes from in the first place. So nitrogen is still going to need 8 electrons, and each hydrogen is still going to need 2. That gives us a total need for this structure of 16 total electrons. The charge, however, does affect how many electrons you have available. Let's go through and calculate that in our normal way. We know that the nitrogen has 5 valence electrons and each hydrogen has 1. So that would be 5 plus 1 plus 1 plus 1 plus 1, giving us a total of 9. We've never really seen an odd number of electrons in this available area, hence why this structure even has a charge in the first place. The charge affects how many electrons that this whole structure has available. Now, if you have a +1 charge, that means that you've lost an available electron. You have 1 less available electron to play with. So we're going to take away 1 from the available area. So again, that charge will definitely affect the number of electrons that you have available. If you have a positive charge, you're going to take that number away from the available. The opposite would be true for a negative charge, and we'll talk about that in just a moment. So in this case, I'm going to subtract 1 from my available electrons because I have this +1 charge. That will give me a total of now 8 available electrons. Let's find out how many we're sharing. So need minus available gives us a shared number of electrons of 8, and that should be approximately 4 bonds. Now let's start to draw this structure. So the first thing I'm going to do is to lay out the atoms as symmetrically as possible. Nitrogen will go in the center with the hydrogens around the outside. Now I'm going to try and connect everything to the center using my 4 bonds. And here we go. I've used up all of my 4 bonds, and I'm pretty much good to go here. I just drew in with those 4 bonds 8 total electrons, and I have only 8 available electrons to draw. That means I don't owe my structure any dots of any kind. Now I'm almost done. Now the only way that this structure worked was by monkeying with the number of electrons, and we saw this earlier in our ionic chapter. Anytime that we draw a Lewis dot structure where we monkey with the number of electrons, we need to incorporate square brackets around the outside, and then an upper right-hand corner indicate how. So in this case, I'll put the +1 charge to indicate that we had to remove an available electron to get this to work. So once again, the charge on the polyatomic ion affects the number of electrons that these things have available. So let's take a look here just at how a negative charge might affect things. So here, for example, is hydroxide. When I go to calculate the available electrons, it would be oxygen plus hydrogen, and then I have to deal with the charge. In this case, oxygen has 6 available electrons, hydrogen has 1, and then with a charge of -1, that means I have an extra electron available. So I would need to add 1 onto my total. In this case, hydroxide would have a total available number of electrons of 8.